this is same difference by Marty Sears. For the rules we have normal Sudoku rules, so every row, column and 3x3 box must contain all the digits from 1 to 9. Then we have these turquoise lines, so and there are same difference lines, so each pair of adjacent digits on the one line, one of these lines has the same difference, so this the difference between these two cells is the same as these two, and also and different line may have different difference, so it could be 1 here and 2 here, for instance. And then we have these orange diamonds. So a digit in an orange diamond indicates how many lines have a difference value equal to the diamond digit. Then there is an example. If there's a 3 in a diamond, it indicates that there are 3 lines whose adjacent digits differ by 3. So if there were 3 there, we would have 3 lines, let's say this one, and maybe this one, with a difference of 3, but no more. So whichever digit goes there, well, it goes one way, but not necessarily the other way. If there were no 3 here, we could have only one line with a 3, or no line, or even 4 lines with a difference of 3. So that's for the rules. Now I will start thinking of this. No, the minimum is 1, 2, 3, 4, which would cover 10 lines. Indeed, one line with it's similar to killer cages, because the sum of these equals the number of lines. So this would cover 10 lines, specify at least 10 lines, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's not much degree of freedom here. So in the case it were 1, 2, 3, 4, there would be 10 lines with this difference and 2 other lines with other difference. So we would have 2 spare lines, but which could not be, which couldn't have a difference of 1, 2, 3, 4. But maybe place 5 or higher. Well, the difference of 5 requires a repeated digit, because let's say here, for instance, 1, which is the minimum, so 1 and 5 give 6. It's like a German whisper line, but then this digit would have to be either 11 or 1 again, so can't be 1, can't be 11. So this line, well, whichever sequence of 3 digits which are the same row or box, like this one or this one, Also this one, well, they must have a repeated digit, so this could have a difference of 4. This possibly, this one, but all the other lines have at least 3 cells within a box or row or column. So this is 1, 2, 3, 4. There are at most 4 lines with a difference of 5 or higher. So indeed this can't work. You can't place a 5 or higher in a diamond because there are only 4 possible cell lines which could have this higher difference. So this is indeed 1, 2, 3, 4. And we have 2 spare lines, or spare difference, which are either 5 or maybe 6 or even higher, but not one of these. We have a long line here, which is 6 cell long, but maybe could have repeated digits. Well, no, I think it can't. Let's see. If it were having a repeated digit, so switching from an ascending to a descending sequence would require this. Let's say if it were 1, then 3, then this one would have to go, could not be a 1 again, so these 2 must be different. So these must form a sequence, and these 2 must be different, so again these must form a difference, and these must be different, so this must form as a sequence as either ascending or descending. So these are all different digits, and there are 6 of them, so it can't be a difference of 2 nor higher, because 2, we have at most 5 odd digits, but we need 6 digits, so this is a difference of 1. And that's the only line with a difference of 1 because it's on a diamond. And well, it's also like a Ren band, so maybe it's more constrained, but so it must contain a 5, but also a 4 and a 6. There's no way to make a sequence of 6 successive cell without 4, 5, nor 6. So there must be a 5. Could it go there? Don't think so. Because 5, if it go up, let's say 6, 7, 8, 9, and then it would place another 8 here. So 9 would place 2, 8. Or if it were going down, this would be a 1 with 2, 2. And here, this were 5, 6, 7, 8, 9. So 9, 8, 8. So this can't be 5 either. Either 9, 8, 8 or 1, 2, 2. So it goes in one of these 4 cells. I know it's cross boxing, but maybe I should think about this one. This can't be a difference of 1. It can't be a difference of 4. It can't be 1, 4, 1, 5, 9. So it's a difference of 2 and 3, but it can't be a difference of 3 because we have 1, 2 and 3 there, so it can't be 1, 4, 7. So a difference of 3 would contain all 3 digits of the same mod 3 set, which are 1, 4, 7, 2, 5, 8 and 3, 6, 9. So because we have one of each in these 4 cells, it can't be have a difference of 3. And so this is not 4. Well, it can't be higher, of course. So this must be a difference of 2. And these have the same parity, so this can't be even, this must be odd. And there's no 1, 3, so it's 5, 7, 9 here, with the 7 here, and 5, 9. And then, so this is 6, 8. And then from 9 we can go 7 and 5. And from 5 we could go either up or down. 5, 7, 9. Or 3, 1. So this one has a difference of 2. This one has a difference of 1. So it's the only one with a difference of 1. Now this one, well, can't have a difference of 1 because that's the only line. So it could be 2, 3 or 4. Can't be higher. But the difference of 4 would be 1, 5, 9 here with a 5 in this cell, but it would rule out the 5, all the 5 on this line, so it can't be 4. So it's either 2 or 3. Well, it can't be 3 because these are 3 successive digits. And they contain one of each mod 3 digit, or they are successive. So it's like this 1, 2, 3 here. This could be whichever triplet goes down. It contains at least, it always contains one of each digit from all mod 3 set. So let's say if it were 2, 3, 4, 5, so 3 would rule out 3, 6, 9, 4 would rule out 1, 4, 7, and 5 would rule out 2, 5, 8. So this is not 1, not 3, not 4. This must be have a difference of 2. Maybe I should color this because this is the 2 lines with a difference of 2. So all other lines must have a difference of either 3 or 4 or some other difference, in which case it would be a spare line. So there we have 2 spare difference, 2 lines which are not from 1, 2, 3, 4. Now these are either all odd or all even. But this line must contain a 4 and a 6. And if it were even, it would also contain a 4 and a 6 here. So either 2, 4, 6 or 8, 6, 4. One way or the other. So this line must contain a 4 or 6. So if it goes there, let's say 4, 5, but this would be 6 or 6. Well, it can't be 6, 7, 8, 9, and then 8 again. Because these have the same parity. These have the same parity, so this would be 4, 5, 6 or 6, 5, 4. Placing a 4 here. 4, 5, 6 or 6, 5, 4. So there's always a 4 and a 6 in one of these. So it would clash with this. So this can't be even. And must be odd. And therefore it must contain 5. Because minimum is 1, 3, 5. The maximum is 9, 7, 5. So there's always a 5 in this line. So the 5 for this line goes here. And we have second digit. These are difference of 1, so consecutive. 4, 6, 3, 7, 8 and 1, 9. 5 gives 9. 5. So it could be 3, but this 5, 3, 1 or 5, 7, 9. So there's a 5, but at the end, so there's 7 pair here. A 159 triplet. So this line, so difference of 4. So we have all lines with a difference of 1 and 2. These are 1 and 2. So we are left with the 3, 4 or something else, some other difference. So this can't be, well, it can't be higher than 4 because it's within the box. So it's the 3 or 4, but 4 is 159, and it can't work. So this is a difference of 3. Well, we use some other color here. For the 3, the difference of 3. Well, it could be anything but 258. So it could be 369 or 147. Well, we don't know yet. And 159. So this line can't be 159 either. So it can't have a difference of 4. No 2, because we have the all 2 lines, no higher or low. 0 is possible, so this is also a difference of 3. Can't be 147 or 369, so it's 258, so 5 there, and 28. So here we need 37 goes here, and we know the other, and this is the other 1 line on this one. Now 3, the 3 goes here. This line also can't be 159, so it must also be a difference of 3, because we have only 2. So it's at the 147, 258 or 369. But it can't be 147 because this is at the 1 or 97. So there's a 1 or a 7 there. And it can't be 369 either because there is at the 9 here or 1, 3 there. So this is neither 147 or 369, it's also 258. 5, 2, 8, I have a 2, 8 pair there. Well, not much useful. So indeed, we have all three lines with a difference of 3, yeah. So all the other lines are either 4 or one of the 2 lines with a spare difference, some other difference. This line, well, it can't be something else than, so it can't be 1, 2, nor 3, and it can't be anything else but a 4. So 159, 5, 1, 9. We have pairs everywhere here. I will put another color for this one. We have the same here. This must be a difference of 4, can't be anything else. Here we know the other. Nine, so 9 goes here. Can't go on this line because it would be either 8, 9, which are a difference of 1, but this is the only line which could be, or 6, 9, which is difference of 3, and we have all 3 lines with a difference of 3 here, so the 9 goes there, which means not much so far. Indeed, what could this be? And this one. On this could be a difference of 0. All 3 same digit, but this can't be because these are different, so this must be at least a difference of 4, and it could be 8, 4, 8, or 6. Or if it were higher, this could be 8, 2, for instance, or 1, 8, 2, something, but these are always the same because there is a difference of at least 4, and this is not neither 1 nor a 9, so these are the same. So what are we missing here? So these are yellow. Well, it could be a difference of 4. So far, all we know is that these 2 are the same digit, which goes here somewhere. If this digit goes here, this would be a difference of 2 because these are different. So this is 1, 6, 8, and this is the other. So if this one goes here, it would turn this into a difference of 2, which can't work. So the other 6, 8 goes here. this one. So what are we missing here? 1 and 6, 8. Well, this can't be 6 or 8 because it would be a difference of 2. Again. So this is the other 6, 8. So this is 1, 6, 8. And this is the other. So this is indeed a line of with a difference of 0. This is spare line, spare difference. One of the two lines which are not from 1, 2, 3, 4. And these are the same digit, but can't. Well, this is 2 8 pairs, so it can't be 8. This is 6. So 8. This is 1, 2. This 8 fixes this line. So 1, 2, 3, 4, 5, and 6. And this one 9, 7. This is a 1. So 9, 1. This involves a lot. We need a 6 and an 8. So 8, 6. We have 1, 2, 4, so 2 here. 1 and 4, 1 goes here. Because of this one. 4. 1 gives 9 and 7. No 4, no 1. So 1 goes here. I might color this line, so let's say in a light gray. This is a difference of 7, so it's not. This is the other spare line like this one. So I will put it in red. I should finish this one. 7, 2, or 3, or maybe this line. It can't be 1, 4, 7, and it can't be 2, 5. Yes, 2, 5, 8. Because of this 5. So it's indeed 3, 6, 9, and we know the 9 is there, so 9, 6, and 3. We need a 6 and a 7. So 7 goes there. This is 2 or 3. Oh well, this is a 2, 4 pair, so this is a 3, 2, 3 and 4. Don't know. The 3 here is, this is the purple line. So now we are almost done. So we have all 2 lines, spare lines. So these 2, we must have 4, 4. So these are the other 2, 4 with 2 there. These are the other two lines with a difference of 4, so 4, 8 and 4. 2 and 8. 2. Here. Maybe I might think of 2, 3, 4. So the 2. Oh, well, this is 4, 2. So 4, this is yellow, and 2, this would be green. So now we have 3 and 4. Well, indeed, the 4 goes down. 4, 3. This is 1, 3. And it has a difference of 4. So it's at the 1, 5, 1. 3, 7, but it can't work. So this is 1, 5, 1. And no, it's just a question of we have all the lines fixed. So let's see. 3 and 5. So 3 there, 5. Or maybe here. 4, 9. This way. 1, 6. 3, 7. 2, 7. And 6, 9. This is a 2. 4, 8. 2, 4. So 4, 8 and 8, 7 to finish the puzzle. And that's it. That was a really nice puzzle, but not easy to find out. So, nice combination of constraint with some reasoning here about this maximum digit which could go there, and then this 159. That was quite a tough deduction, but it's really nice.